All right, so thanks everybody for coming today. I hope you're all having a really good Dev Summit. This talk is intended to help you get a deeper dive on scene layers, which are an essential concept for sharing and publishing 3D content in Esri. And so I'm Chris Andrews. I'm the 3D product manager for Esri. I work with a small team of people that are product managers for other specific areas inside 3D, like urban planning, BIM and CAD, and then some of the defense solutions that we have, like ArcGIS Earth and now ClearTerra and some of the PAR software. And then with me is Tamrat. You want to go ahead and intro?
I'm a software developer within the 3D scene team, and I've been working in spearheading the I3S standard and specification, and working with Chris and others on the team to bring 3D content.
Yeah, so the goal today is to kind of do a little bit of overview and then some deep dive, and to try to make sure there's time for questions at the end. So, all right, let's see, in advance, okay. All right, so there are massive amounts of, and some of you have seen this slide before, but it doesn't hurt to see it again. Just massive amounts of new data types that have emerged in the last couple of years, and also new uses for old data types that are all potentially 3D. We see IoT data, truck and ground and student-mounted LiDAR units, drone data capture, imagery, right? Oblique imagery workflows that can lead to 3D. And all of this new data, all these new data types are driving the demand for new GIS experiences. So we're starting to hear about more and more Unity integration and Unreal use of GIS data for game-like experiences. We're hearing about wearables. We're hearing about all kinds of things, right? So I think you're all aware of this. Hopefully, if otherwise, I think you'd have to be hiding in some cabin in, Idaho or something like that. One of the reasons that I talk about 3D, and some people say, why don't you talk about 4D or 7D or ND or something like that, is because 3D has just become this common vernacular, common reference that almost anybody can understand, from my sister to a highly technical developer to a scientist, right? So we experience the world in 3D every day, and 3D has become, in kind of technology usage, a focal point for many other changes in technology expectation about experience in the last few years, including the need to be visually compelling. So I will say that I've been talking about visually compelling maps since before Jack talked about having beautiful maps earlier this week. He started to talk about the need for beautiful maps. 3D is one place where people go for visually compelling maps. Deep and smart behavior, real-time integration often comes in when people start talking about 3D, because once you can see the scene of where you live, you want to see where the buses drive through it, or whether buses are driving through it right now, for example. Mobile usage, immersiveness, and then certainly consumer level usability. All these things tend to come up when you start talking about 3D experiences. So 3D has intrinsic value that is different from 2D in the GIS industry. And I don't know if some of you will remember that years ago there were lots of books and articles about the business value of GIS. Well, in fact, some of the value of 3D is not this analytical business value, but it's a little bit more emotional IQ type value. But one of the things that I never would have said a few years ago is this thing on the upper left. I've really just started adding this and talking about it in the last few months. 10 years ago, 12 years ago, people would have had conversations about 3D potentially being a more accurate version of the real world than 2D, but nobody would have back then really thought that was conceivable because of the difficulty in collecting data. And now we can see these massive point cloud collections. Like we got one published today, 43 billion points for part of the Netherlands, and extremely high res oblique imagery from which you can generate 1 centimeter resolution or better textured models of buildings and other assets. we are at the point today where 3D can be a more accurate representation of the real world than 2D. You use 3D to visualize stuff you can't see. This could be in the future, this could be in the past, or this could be simply under your feet. 3D is often more useful for communicating with non-technical stakeholders than 2D maps, and I've seen this at practice, in play with somebody trying to use ortho photos to show a bunch of senior citizens where their homes were in relation to a construction project. They were looking at their homes and could not figure out where their house was on the ortho photo, but put a 3D model of it in front of them, and they knew where they walked every day in this development. And then you can analyze behavior and aesthetics in 3D that you can't in 2D, right? What does brick look like in 2D, right? It's in a 2D map, right? You don't see the brick in a 2D map. So these are some of the intrinsic values that 3D can bring to GIS. So my role has been to promote the adoption of 3D across ArcGIS and across GIS in general. And these days, I think I've finally heard Jack and others say, well, GIS is 3D. But it's taken a few years to get there. At first, 3D was looked at as kind of a bolt-on or extension or extra product in the ArcGIS family. But now we have 3D solutions on web, on desktop. We have SDKs that are starting to be used for things like AR and VR experiences. We have 3D in the back end, and we offer 3D content. There are this is a developer audience, there are tons of opportunities for developers with 3D. Many of them are traditional GIS workflows now just translated into modern data types and experiences. There are other things that people are demanding, such as generation of 3D content into new layer types that are being released by Esri and others. And right now, that is definitely a developer's world. We don't even have an SDK for some of these data types yet. So that's a place where we're getting a lot of interest. Content conversion is a huge one right now in the industry. Tam and I are constantly talking to people about how to convert content and programmatically, doing things like integrating 3D into dashboards and web apps, right? So all kinds of stuff. A lot of this traditional things that you can do as a developer in 2D GIS now can definitely be done with 3D, or people are asking for it. When we talk about 3D technology here and tools, it's really useful to understand a couple basic concepts, and this is what Tam's going to dive into a lot more deeply today. Web scenes are containers for 3D and 2D layers and other content. The container is a JSON descriptor at the end of the day that is interpreted by a client and realized as a TOC and legend and layer orders and all those kinds of things. We are later this year introducing a mobile scene package, which is a persisted version of a web scene with persisted data, all wrapped up into an archive. And then scene layers themselves are these in one flavor of them is there are these large transportable caches of 3D content. They can also exist as services and be tied to other mechanisms that allow them to be a little bit more dynamic than just a visualization cache. Last year, we were really happy to see that I3S, the specification for scene layers, was adopted by OGC as a community standard. This has been a tremendous, what's the right word? This is a tremendous event for us, especially in conversations around federal government in the US, federal government utilities and all kinds of folks in the EU, and certainly in Asia as well. So right now, Esri has the standard in OGC for heterogeneous, large cached GIS content. And we're going to be expanding it. You can use it without any Esri software. You don't have to have any royalty or license with us to use it. And we are already seeing some pretty fantastic adoption of it. I'll just briefly touch. So hopefully everybody in this room knows that we have 3D in desktops these days. So we've got Pro, which is this 2D, 3D authoring tool for GIS users. And then we have City Engine, which has been repurposed for advanced urban planning workflows. We have apps, and I'm actually happy to say for the first time I've got a prototype, at least, Android 3D mobile app that runs on my phone. I think Cam's going to do an iOS demo as well, and hopefully this year we'll see, at least in beta, the first 3D app that will be headed toward production from Esri. You guys could code apps in 3D right now if you want. Online and enterprise, the only reason I mention this is 3D requires the portal information model. You can't go against the old server-style services to access the scene layer content. And then we do offer content. The second most used layer in ArcGIS Online is the 3D world elevation service. The first one being our imagery base map. So we offer this now 24-meter posting or better, because we just updated it with new content, global elevation service that is what you see when you open Pro and you're connected to online, or you touch the WebGL experience, or Earth. And then, I am a developer by background, and everything that Esri does has a developer flavor for it. And this is true as well around capabilities. So you see 3D now in the runtime SDKs and WebGL, in the Pro APIs. So you can touch 3D as a developer all over the place. All right. In 2017, just to touch on things, we made I could not list all the things we did in one slide, but we are making changes to the core information model, including we're the first GIS platform, open source or otherwise, to have a vertical coordinate system definition. And that's very important because, like, if you are a surveyor and you're measuring something, you're measuring in a gravimetric model where your head is pointed not exactly directly away from the center of the Earth, but if you're cooking 3D content from satellite imagery, up is directly away from the center of the Earth. So we needed to give our users ways to combine those data so that they do occur at the correct location together. And so we introduced a platform-wide vertical coordinate system concept, and it's a critical part of supporting accurate 3D. That's just one example. There's so many different things that have been going on. All right, so I'm going to move to Tam now.
Sure.
And give you back the mouse.
All right, thank you, Chris. So I'm just going to dive into what is a shareable content in 3D. As Chris said, I think any realistic 3D scene starts with elevation. Elevation is your basic ingredient. Is it there? Okay. Let me just click in here, I guess. Okay. Elevation is your basic ingredient that you start off your 3D scene. So elevation, first primary source of input data for creating a shareable 3D content is the one. And then you can, a lot of people do this, you can easily create 3D content out of 2D feature layers by simply extruding those features into simple boxes that actually represent 3D scenarios. So draped features or 2D features that are extruded or draped are a good way of quickly creating a shareable 3D content. And then if you want to take it one more notch up, you can take your point feature classes symbolized by the 3D symbols. Recently, we actually allow you to have custom 3D symbols also be able to be shareable on the web and also on portal in ArcGIS Online. So these are the easiest way to actually create a 3D scene out of 2D ingredient and elevation data that you have. And then we'll spend most of the time today talking about indexed 3D scene layers, I3S. What is it? How can you create it? How can you consume it? So we'll spend most of the time discussing about that. So as I said, the first starting off. So one of the things that you'd probably make a decision from the get-go is, am I going to be publishing a local scene or a global scene? Now, some local governments and city governments have requirement that the data needs to be published in a particular coordinate system and projected coordinate system or not. So the system allows you to actually decide that. You want to go local coordinate system, a projected coordinate system, or a global geographic one, so you can make that decision. Then, as we stated earlier, elevation is your basic ingredient. The scene always starts with elevation. Having a realistic elevation is always good. ArcGIS Online and Portal come with already ready-made elevation. And as Chris mentioned, we added the Airbus data that also greatly increases the realism and 3D fidelity of the scene. So be free, it's out there for you. You can use the elevation sources that we have on ArcGIS Online and Portal to enhance your 3D scene. Now, same thing goes for Imagery. The base map Imagery available on online and Portal is also a good starting point. But you can also bring in your own content, your own local imagery that could enhance the scene much more greater fidelity. It is also a good way to increase the quality of the scene. And then I3S layers, 3D scene layers. These are your 3D objects, your points, your point cloud, and integrated mesh layers that actually absolutely increase the quality of the scene that you would see. We see that a lot of people now want more realistic scenes as opposed to cartographic representation, though the cartographic representation also has its own value. But people are more and more pushing towards getting more realistic scenery of their 3D environment. So I3S is capable of capturing that type of data content. And then, as I mentioned earlier, your 2D feature layers are also a good participant in creating your 3D scene. Extruded lines and points and even polygons extruded into building boxes are a quick and dirty and easy way of making good 3D content. So now you have created, so assume that you have created that 3D scene. You've added all the content that you want to do, you want to add to it. Now you are ready to share it. Share that to the public, to your organization, or to the masses at large. So we have kind of two approaches that you can take for that. First is using ArcGIS Enterprise. ArcGIS Enterprise, comprised of ArcGIS Portal, server, and data store, is one medium that you can actually share this content. Once the data is composed, and ArcGIS Pro desktop application is typically used for doing that, then you'll be able to push out that content either by directly connecting to the ArcGIS online resource or ArcGIS Portal resource, or by generating a local data, which we call a scene layer package. Now, from the get-go, you're already able to consume this content in all devices, desktop, web, and mobile devices. There is not any additional thing that you need to do per se to enable it for mobile or desktop usage. Content itself comes ready-made, consumable in this environment. Now, one aspect of I3S is the scene layer package. A scene layer package is just an archive file that constitutes all the rendering resources that are required to visualize a 3D scene layer. And a scene layer package is awesome in that you can actually use it to render directly from. That's what ArcGIS Earth does, ArcGIS Pro does, can directly render from it. But it can also be used as a transportation medium. It can be used to transport your scene layer cache or scene layer content from here to the client side to the server. And it can be exported out and handed out as a web service resource. So scene layer packages are also a good way of composing your scene, and then just kind of think of it like you're putting all in one bucket and just uploading that to the portal or online, or actually your own Azure or Amazon S3 environment to host that content. And we'll delve into that a little bit. So ArcGIS Enterprise, one route to actually share your content, and also now increasingly ArcGIS Online, especially with ArcGIS Pro 2.1 being able to directly publish from ArcGIS Pro to ArcGIS Online. We've seen a lot of users actually gravitating towards that route. It's online. It's an environment that is managed by Esri. They don't have to configure their enterprise resource. So that's also one viable way for sharing content.
Last time I looked, I think there were something like 45,000 publicly and privately shared scene layers up in ArcGIS Online already. So that's quite a bit.
Yeah, that's a great improvement lately we've been seeing. And the one thing that really pushed that probably is the ability to directly push out content from ArcGIS Pro to ArcGIS Online. And this has been really a great way of sharing content directly to people that might not have enterprise environment. Now, as Chris mentioned earlier, we've seen a lot of data providers, at least we can count off top of our hands, like 6, 7 or more, that are actually churning out content in scene layer package format. Scene layer package format, and we're seeing actually users asking for that content, going back to the data provider and saying, hey, we want Esri's I3S content. And because it's an open standard, anybody can actually create that content and share it. We're seeing a lot of data providers actually outputting a scene layer package that could be shared in our cloud infrastructure or anybody's cloud infrastructure for that matter. Scene layer package, again, could be directly consumed by desktop application, ArcGIS Runtime, ArcGIS desktop and mobile applications, I should say, actually. The ArcGIS Runtime SDK can directly consume it, as well as ArcGIS Earth and ArcGIS Pro can directly consume a scene layer package without needing to extract the content out. And we'll see a little bit more in depth. So what are the platforms so ArcGIS is a vast platform, so there are many applications and tools that are within the system. Where are scene layers supported? Almost everywhere. So the first one that we mentioned earlier was the ArcGIS Enterprise system, where you can actually publish the content directly by connecting to the ArcGIS Online system from ArcGIS Pro, and also directly logging into the ArcGIS Portal Enterprise by uploading your content. One thing that we released with ArcGIS 10.6 is the ability to upload your feature database, your file GTP, to online or portal and be able to actually instantiate a scene service out of that. That is a really cool way of immediately creating content. Now, a lot of people prefer the other way or use the other way, which is have an editing environment like ArcGIS Pro, compose in the 3D scene, and then push out their content from there. So ArcGIS Enterprise and ArcGIS Online are the premier applications or environments that you can publish scene layers to. But that's not the only thing. Drone to Map, an application that actually leverages Dane's photo matching processes to generate meshes, is also capable of generating a scene layer package that you can take and publish. City Engine, Chris mentioned earlier. Every City Engine is also capable of churning out a scene layer package, so you can really make this great, amazing scenes in Esri City Engine and just export it out to a scene layer package and share it to online or portal for users to consume. And of course, last but not least, ArcGIS Pro is the premier desktop application that people use to compose these 3D scenes and also push out content directly from it. As I mentioned earlier, one thing that we added in ArcGIS Pro is the ability to locally generate the scene layer package and publish that to the ArcGIS Online or portal resource. And this has been a really good way of leveraging, in some instances that you might want to be able to leverage the desktop machine that you have here as opposed to the server resources residing on the portal or enterprise system. So if that is the option, we actually now include with ArcGIS Pro 2.1 ability to generate the cache locally and just upload the scene layer package directly to portal or online.
Yeah, and just a quick comment is we are seeing some people run Pro headless to generate content as part of an automated workflow. So it's an interesting workflow that we're getting some demand for.
Yeah, definitely it could be used for that purpose as well. On the consumption side, the web obviously is a big consumer of scene layers and I3S. You can consume it in enterprise and online, as I said earlier. ArcGIS API for JavaScript is also becoming a big player here in consumption of scene layers. People are building applications and widgets based consuming a scene layer in the ArcGIS API for JavaScript, and that's also one way that or one environment that is getting a lot of traction. And finally, and then the desktop environment, we mentioned ArcGIS Earth, ArcGIS Pro are also consumers of this. And ArcGIS Runtime. ArcGIS Runtime running SDK applications built around the ArcGIS SDK, around the ArcGIS Runtime can consume that. And we'll have a few demos to show you here. So we can consume I3S or scene layers in online, enterprise, desktop, mobile, across the platform, really. And that was the premise when we started off with the I3S. And I3S, we wanted to be open standard for storing and transmitting large amounts of geospatial heterogeneous 3D content. But we also came out with the principle when we designed it, it needs to be cloud-friendly, web-friendly, and it needs to be based on some of the modern JSON and REST APIs that actually power these things. As I said, the I3S allows you to support, it allows you to publish 3D geospatial content in various coordinate systems. You can either publish it in projected coordinate system or geographic. And also, we now, actually, as Chris mentioned earlier, support vertical data. So you can actually publish your content in orthometric or ellipsoidal and be able to consume it back in the application that you want to consume these things. Just delving into the I3S a little bit more, yes, it has now become an official OGC community standard for streaming 3D content. We put a lot of effort in this, and we're happy that it is finally adopted by the OGC as a community standard. And we've already seen traction on that, especially in Europe. Standards are big. And not only that, just the standard is big now, third party and people that want to innovate around it are also taking it and modifying it and sharing it. It's released under the Creative Commons. Both I3S and Scene Layer package are released under the Creative Commons license, so you're free to innovate and use it without any royalty, as Chris mentioned. So the I3S standard specification lives in github.com Esri I3S spec, but there's also the OGC version of it. Now, this one is a living, breathing document. We'll be evolving it more and more as we put more features into the standard. We'll push and then gradually, pick up a sync-up point with the OGC version. For now, right now, they are in sync. The OGC version is 1.6, same as ours, but we'll be putting more and more.
Yeah, I think we do get a lot of questions from, especially the data vendors on what is the synchronicity of the I3S spec in OGC versus this public Creative Commons spec versus what we actually release in software. And so, in a way, there are really three flavors of I3S, of this spec, and it's a necessary part of the process of getting it through the standards process, but also using it in active software. So there's a version that we are working on where we're adding new functionality, so new layer types, new pieces of the profiles in the existing layers, and that is the spec that is kind of in active development. We don't share it with partners because we don't want them to be churning on stuff that's changing, and that when we ship software, that's when that gets updated in the link that Tam's got here.
Right.
So this is typically, with a couple of exceptions, it is typically the latest and greatest that is in shipping software. Right. There have been a couple minor exceptions, such as the point cloud spec, which you might talk about a little bit more. That had some IP issues that we needed to resolve first, and then that is
sure. Actually, good.
So that's potentially ready for release, and Tam can address that more. And then there's the OGC version, which needs to go through a standard OGC standards process. So that one is always going to lag behind this thing here, which lags behind what we're doing inside Esri in development. So I just wanted to call that out because we do get questions about how is the OGC spec in comparison to what is at this link, and so it's kind of one, we develop it, then we release it here, then we will push through updates or have our partners help us push through updates in OGC. So it's a really dry topic, but it does matter when you're a content creator and you're trying to figure out what is the best thing to work against. So, all right, enough said there.
No, that's good. In fact, actually, I can piggyback on that. We just released today, like 5 minutes ago, and I can show it, the draft specification for point cloud layers. And this is exactly what the process that Chris was mentioning, that we'll release it into the GitHub Esri resource, try to get it ingested into the I3S specification that we have, and then take that to the OGC. And that way, it will let the standard specification mature a little bit before we actually take it down to the OGC for adoption purposes. So, a quick rundown. Web-friendly, mobile-friendly, I mentioned it, extensible. These are all the things that we needed to hit, actually. This is the design spec sheet, if you will, that we had 3-4 years ago when we were designing this. Needed to hit all these things. And two maybe ones that would stick out extensibility is very key for I3S. You'd see this 40 billion points point cloud layer in an integrated mesh that covers the entire city with gigabytes and terabytes of data. All that is kind of supported now because the original premise is that the content should be extensible and we should be able to add new types like we have done with point cloud. With the I3S principle was out there for almost 2 years plus, but now we are able to join point cloud, the detailed specification of point cloud into it. So these are the few points that we needed to hit. I don't need to belabor it here, but just wanted to share here that I3S actually addresses all these points that you see here. So now let's see what are the type of layers that are really supported. There are 4 types currently that are supported. 3D objects, points, integrated mesh, and point clouds are the profile types that are currently supported within I3S. 3D objects are your typical, 3D object buildings, and typically these are data derived from GIS 3D models. We have tools within the ArcGIS system that actually allows you to import models that were created either by hand or automatic process into the ArcGIS format, and then be able to generate our tools that allow you to cook this multi-LOD, multi-resolution hierarchy format, which we call the I3S for sharing. So 3D object is the first layer type that we actually supported in I3S. And then comes in the integrated mesh. Integrated mesh is very much similar and related to 3D objects, but it has its own unique points. So an integrated mesh is this mesh surface representing the skin of the earth, including vegetation, building, cars, and whatnot. And it's typically derived from either satellite resources or aerial or drone imagery via dense matching photogrammetry processes. We see clients actually now with data partners churning out this content use this as a base map. It's a really cool way of quickly creating a 3D scene that is scalable in a sense that you can repeat this process very easily a couple of years when things are updated, and immediately brings this rich fill-in look to your 3D environment as a scaffolding, as a backdrop that you want to use your data, your other GIS data along with. So 3D objects, integrated mesh is the second layer that we have support in I3S. Then comes points. Points, your typical point 2D feature class, Z or without Z is supported. But as soon as you actually use a 3D symbol to symbolize it, it becomes really alive. So it's a very easy and quick way of creating realistic 3D scene environments within the system is using point feature class and symbolizing it with the either with the library that we ship with the application, both ArcGIS Pro, an online portal. There is built-in library set that you can use to symbolize the scene, or you can even bring in your own models in Collada, 3ds, VRML, and maybe one more format that we are able to import in as a model to represent the scene. So points is the third layer type that is supported within I3S. And then lastly is point cloud. I'm really happy to say that today, like 5 minutes ago, we just shared the specification for point cloud. Though point cloud actually has been, point cloud scene layer has been shipping within the product for the past year and a half, over a year now. But exactly the process that he mentioned earlier, Chris, that put it on our software, get it adoption, get it and really kind of make sure that the things that we set out, that principle that we set out, really works with it. And then when we're ready to share the standard or the specification in our GitHub resource, then take it also to OGC once it's ready to be adopted. So point cloud layers are also typically sourced from LiDAR datasets, are also the fourth type of layer that is supported within I3S. So how is data organized in I3S? I3S organizes information using this hierarchical node-based spatial index structure in which each node payload may contain features associated with it, with geometries, textures, and attributes. So imagine you're looking at the the slide that you're looking at. You have the blue boxes that represents the node resources, and these are the IDs or the addresses, if you will, that a viewing application will traverse the content to fetch that content. And the green ones sort of represent the actual payload, and these are the geometry, texture, and attribute that are stored within that node resource. So the key thing about I3S is this organization of data into hierarchical node-bound or node-based, minimum bounding volume-based content. So meaning that a viewing application will never have to request rendering resources, geometry, texture, attributes, until it's ready to render that particular resource at a particular level of detail. And this is a key difference between the other data types that we had in the past and supported, that this skeletal node index document that allows you to traverse the data and content and allows you to make a decision about what level of detail that you're rendering on the scene is very cheap and is very efficient to be transmitted. And only then and then you will actually fetch the content, geometry, texture, and attributes that are associated with it. So this organization of the data using hierarchical node-based bound spatial index structure is a key point about how data is organized for all I3S layer. Point, 3D objects, integrated mesh, point cloud, all subscribe to this principle.
So this is how some of the scene layers get extremely large, right? The largest one that I've had my hands on has been, on a file, has been 120 gigabytes as a single file of I3S content. And you can upload that to, say, online or enterprise, and then you can view it on a phone. Well, you're not downloading all 120 gigabytes to the phone. You're just downloading what you need for the view that you're looking at at the time, or the analysis that you're doing. So
yeah, and that's key. And we'll show now that you can consume this very large data sets, gigabytes in SLPK, or some of them terabytes could end up actually when hosted on the online and enterprise environment. But you will never be fetching the whole thing at one given time. Only what you need for that level of detail. So. Quick rundown of the content of the node. So the previous slide that I showed was a schematic, representation of what it looks like. But if we delve into it, what does a node really consist of? 4 resources really. The node index document. This is just a lightweight resource that describes the topology, as I said, the minimum bounding volume and topology. There is a shared resource document. This is a descriptor document that we use for material and image resources. It indicates, if you have a material resource or image is described in the shared resource document. There's a feature data subdocument. This is an optional document that actually has an identifier set of information that tells us, what is the mesh segmentation information, so that we know when you click on a building that we know that is building ID, so and so, or building either is an Eiffel Tower. So that information is stored redundantly, I should say, in the feature data document, because we also capture that information in the geometry data, the geometry binary data, which is the third resource, so that client application can actually know not only that they have the triangles and vertices that are stored in the geometry data, but also the information that tells them what range of triangles constitute what building, so that when you click on a building or do line of sight or that kind of analysis, you would know what is hit by that process. So the binary resources then are the geometry and texture. And texture, we have a multiple texture, more than one texture resource could reside in the same node, so that some of it could be optimized for rendering for a desktop application, mobile application, or for both. And then lastly, attribute data information. So I3S also captures the attribute information associated with these layers, so that you can do attribute-driven symbolization. You can symbolize all your buildings with a given color or a value driven by the attribute information. Okay. Another topic in I3S is the LOD selection or selection metrics concept. So I3S promotes this concept of discrete levels of details where multiple levels of representation reside in the hierarchical tree. One example of this selection criteria is the maximum screen size. So basically, a rendering application would already know what level of detail it needs to be fetching for that given node index document that it got. And based on that, it can determine whether it needs to get like a higher level of detail or stay with what it got. And this is what this maximum screen size property that is already pre-computed during the data generation time is used at. It's almost a quick and easy way of telling the client, hey, what you have right now is good enough to be rendered or not. And if it's not, just descend down and get the children or the next level of detail that is associated with this node. I3S consumption part, as I said, has kind of have two facets to it. You can consume it as a RESTful via RESTful interfaces. The first thing so when you take this I3S content, scene layer package, and upload it to ArcGIS Online or portal, what happens behind the scene is that we'll actually, explode the content, put it into, into a cloud storage medium, and then provide a REST interface against that, so that you can just query for it, just a URL, you can get that. So we have that RESTful API on ArcGIS portal and ArcGIS Online that allows you to explore the contents of I3S. But that's not the only way. If you wanted to leverage, Amazon S3 or the Windows Azure cloud storage infrastructure, which already also have some REST API, you can also do that. There's no limitation or restriction that you have to abide by only just the ArcGIS portal or online way of doing it. You can use any REST API available out of the box, and we've demonstrated and shown that people have already done that, especially in environments where they have other key value stores already in their system. And then on the flip side, the other way, as I mentioned earlier, was the scene layer package. And scene layer package is a medium used for transporting the data. Of course, you can use it to upload it to your online resources and use it as an ingredient source, or directly read from it. So Desktop Application Pro runtime just directly can read into the content, and they can do so because the way that the data is organized is that it's an archive, but without any compression. It's just a store. But individual resources are compressed. So what that means is that when you look at the archive, the scene layer package is just as good as a zipped or highly optimized package that you would have. But a consuming client does not necessarily need to explode it out or extract it out before it can traverse the tree and consume it. Only then and then, when it's about to render that geometry, then it can actually extract it from its. Currently, we allow storing it as a gzip, the individual resource, not the whole archive. Then at that point, it can extract it out. So here's a schematic representation of what a scene layer package looks like. The metadata JSON, the entry point to that scene layer package is metadata that describes the number of nodes and content within it. And then the key entry point to that is the 3D scene layer JSON. And this is the resource that is used to define the layer type, the store, the type of content it has, whether it's textured or not, or whether it has attributes or not, is also described into that layer. So this is the typical layout of a scene layer package that allows you to do, that is used for transmitting and also rendering. Now, okay, we're running. Let me quickly hit what is new in the 10.6 and ArcGIS Pro 2.1, and also in the online and web resources. Then we can do a little bit demo for the next 10-15 minutes. With Pro 2.1, we now actually support the Create Scene Layer package. The Create Scene Layer package tool now supports ZLAS and LAS-Z. This is LAS-Z, LAS, and ZLAS. And this has been a feature that has been requested by a lot of data partners, because a lot of people already have LiDAR dataset in that format. So now it can directly allow you to do that. It can either do a file or folder, and you can actually generate a point cloud scene layer out of that. The validation layer package tool, we've improved it to support 3D object, integrated mesh, point, and point cloud. And this is key especially for data providers that are churning out this content. There is a tool within Esri suite of GP tools that allows you to validate the content that you generated. As far as consumption in Pro and ArcGIS Pro goes, users now, here's another thing that was actually requested, ability to be able to hide a building. So you publish this base map of a city, a 3D scene layer, 3D objects for that matter, and now you have some data that you have gotten from a local provider or a building, just one building you're interested in, hiding it from the or masking it out. So we do allow you to hide a selection for 3D object layers and they can also flip back to show it and back and forth. And this is a good way of having the ability to integrate more content without having them conflict with each other. Definition queries on a scene layer is also one new feature that we said. Now we can set a definition if it has an attribute resource information with that particular scene layer, points and 3D objects. You can actually set a definition query against what you would be seeing. As well as limiting the point display limit for point clouds, and point density is also allowed at the consumption side. As a consumer of the resource, you will be able to do that. We added a lot of stuff, but yeah, just going through it. Unique value symbology support. This is also a cool way. So you published your scene layer, and you've symbolized it with some default symbology. But now you want to overwrite that. On the client side, can I be able to overwrite that information that I see with the attribute information that are stored? And yes, you can do that for both 3D objects and points. And this is a really cool way of really enhancing the scene. You're not now bound to only publishing it with one fill and look, but you can actually overwrite that information that you're getting for a particular scene layer. Let me jump onto the sharing. You'll have the slides for reference. Scene layers can be shared directly to ArcGIS Online. This is a cool feature. Before, you only had to actually generate the scene layer package, upload this package to online or a portal, and then spawn a scene service out of it. Now, you can directly do that from ArcGIS Pro. Just connect to the online resource and just publish to ArcGIS Online, and it will do the job behind the scene. When publishing web scene layers, they can be cached locally. I mentioned that already earlier. And then custom styles. So I think in starting ArcGIS Enterprise 10.5.1, we allowed you to have like a style gallery, a built-in style gallery that you can choose some symbols from there. But now you can bring your own styles. And this is cool that if you have already preset styles for trees or cars, whatever it is, now you can actually bring in your own content, put it on the ArcGIS Online or enterprise environment, and be able to use that style, that custom style that you authored for yourself. Here's a few improvements for point scene layer visualization. This is particularly in relation to the web scene viewers, relative to scene elevation mode, callouts. This is cool for text. Now you can show text with callouts, labeling and decluttering, and improved depth perception is also some of the things the web scene team has been working on. Smart mapping, one of my favorite parts, is the ability now to be able to dynamically style or symbolize your scene without really reauthoring the content. So, and I can quickly show that in the demo, that you can actually, on the fly, change the stylization of the scene for the same layer without, and the performance is great, and we can see that. The measure tools has been added within the web scene viewer. So, without any further ado, let me go to the demo real quick and show you a few things. Here's one favorite data of mine. We just got it recently, about like 4 days ago or so, or not even that. This is a data that has been captured by Aerometrics, a data provider out in Australia that is pumping out a scene layer package, and this is for Melbourne. And the data is, I think originally, this is just only a portion of it, but the entire thing is about, 160 gigabytes or so. Once you create the scene layer package, you can just drag and drop it into the view and visualize it. So this is an integrated mesh layer, that captures both the buildings, the trees, and the car, everything within the scene. You see, it's very realistic.
So this is created using Bentley's context capture.
Yeah. So Aerometrics leveraged Bentley's context capture to generate out this kind of scenes, but very immersive environment, very cool and visually rich environment. But now, one of the things that I didn't mention in the slides, but one of the things that we've done in ArcGIS Pro 2.1, and also we'll try to replicate the same things over all the other application, is the ability to do some interactive analysis. Now I can actually quickly do a view shade. So, and I can add another one, actually, maybe here. And this is really cool way of doing some visual analytics. You can see, the red areas are the ones that are not visible from that vantage point, and the green ones are the ones that are visible. And this is just a newly added feature within the ArcGIS Pro. I don't know if City Engine already added this.
Yes, City Engine
on the plan.
at the same time.
Okay, so City Engine also has the same feature, and we'll probably want to bring it also to the web.
Yeah, so any content in the scene can be used for these interactive analytical tools.
Yeah.
So, and that goes for scene layer content.
Yeah, and then you can change, some of the parameters of your layer.
It also doesn't matter if the layer is coming from the web or locally
Correct.
on the machine. Yeah.
Correct, and that's the point, that any I3S layer, whether it's derived from a scene layer package or from as a scene layer from a service, would be able to participate in this. Okay, now the same thing could be consumed also on the web. Now, one of the things that I mentioned earlier is the ability to, stylize your scene and be able to dynamically change it. So I have here a web scene that actually has City of San Francisco. You'd see that if we switch to the legends, you'd see that some of the buildings, you see that, it's a walk time to stops, including planned routes. Cool thing about this is that I can go in here and pick up a layer, and I think this is the buildings, and say configure, and be able to change the style, and I'll choose maybe a different palette.
Down below.
Down below right here, right? And maybe select this one, and done, and done. Or actually, here, I should select a different, let me see. Do I have the right layer? That's walkability future. Actually, that's the one that I need to go back. So let me go back, cancel from here, cancel from here, and walkability feature is the layer that I want to configure. So immediately, what it will do is it will connect to the scene layer resource and be able to actually visualize or change the attribute values that are associated with it. So as I said, I'll go ahead and change this one, just the color, simple thing, for example, done. Immediately see it reflected in the scene. That this did not require refetching of the content. This is almost automatic, as you say. And in fact, I can also change even the, not this one, but the types here. You immediately got a different representation or stylization of your scene without really having the pain of going through refetching the data, because the attribute information that is associated with this, that is driving this stylization, is already stored or fetched along with the attribute data that we saw in the earlier slides. So dynamic stylization is one cool feature that we have, actually allows you to dynamically stylize your scene and be able. But then I always go back to the texture scenes. Here's one from Pictometry that always is immersive. This is for City of San Francisco with the texture buildings, the schematic or thematic buildings that showed, the walk distance from a particular transit line are cool. But oftentimes I see people just be attracted with the, textured representation. Going on, point cloud. I forgot how many billion points this particular point cloud
I don't remember, yeah.
But in the, I don't know, 20, 30 billion points, point cloud data, but if efficiently being streamed and visualized here.
Are you on just the convention center Wi-Fi?
Yeah, I mean, just connecting, nothing. We'll go to the phone, actually, which is even better. It just works fine. It's scalable. And now, you not only have just a visual representation, but also, you can actually have also the attribute information associated with it. Go back to my slide. You can do identify and be able to, find any attribute associated with that particular information, or stylize it back. Again, stylize it with whatever symbology that you'd like to see. We're running a little bit out, so real quick, let me show on the phone. It's 4. Okay, so one of the things that we've been working also is being able to consume this thing in mobile resources. First, I'll show the iOS SDK sample that we have. This one you can actually directly, so you can download it now. This is the iOS SDK sample for runtime, and connect to scene. And you can see I'm not even on Wi-Fi, just using the LTE. Let me go to scene layers and open up a layer that is already stored within it. And I should be able to navigate. Usually the buildings, start appearing. This has both untextured 3D object buildings as well as textured 3D object buildings within the application itself. And then if I zoom in, I think there's a castle. And also you probably might be able to see some 3D, some point features symbolized with a tree. So really immersive and interesting scenario. Again, the same layer that you published for desktop consumption would also work in here within the mobile device application. Or if I go maybe back to Chrome, I'm just going to pull the same layers that we've seen here. So first one that we're seeing is, I think, the New York City LiDAR dataset in point cloud. Same representation. Go to bookmarks. Have the same kind of experience that I would be able to select my building and see it. And even some of the demanding scenes, like the ones that we saw, mobile bookmark, maybe let's go with this one.
Tam, why don't you continue to do a couple demos, and but I think we want to take a couple questions.
Sure. I'll just do that. Why don't you open it up for questions at this point, actually?
So we got about 5 minutes left. Do you folks have any questions on what we've presented today? Yes, sir.
We see a lot of points and polygons. How much effort goes into polylines and then
Sure, I didn't hear the last part. How much effort's going into polylines and
without needing to upload to create a polygon?
Right. So basically, we now have to recreate every layer type plus in scene layers, right? We've sketched out the basic design and the requirements for it, and it's basically just waiting to be queued for development. So I think we understand what the spec is going to look like, and then it's just the hard work of making it happen. And we typically are trying to make it happen in the server side and in at least 2 clients at once, with one of the clients being pro, because that's the author for some of these things. But we know it's needed, and there's a little nuance to the 3D lines, such as linear reference attributes and things like that people want. And so it's not just a conversion of the 2 and 3D feature class lines into 3D. So that we're trying to be a little bit smarter about what we're doing, so that it's kind of not future proof, but future resilient anyway. Another question? Yes, sir. I'm sorry? Does global scene support underground data? So yes, there's nothing. But with nuance. So in Pro, so the data itself definitely can. Global data can be created that is underground in i3s. ArcGIS Pro right now is the only client that has an out-of-the-box experience for exploring that data underground in a global scene. And so everybody understands a global scene is like a whole Earth scene with the blue marble, and local scenes are Cartesian and non-Cartesian coordinate systems that typically are kind of flat 3D, where everything is, it's not curving around the Earth. So the JavaScript viewer does not let you go underground yet in global scenes. That's planned for later this year. And runtime does not let you go underground in global scenes, and that probably won't happen until 2019. So I have seen some customers hack the JavaScript API and go underground anyway. So but that's not for everybody, right? Although this is the developer summit, so maybe, you know.
In practice, it's probably more suited to have a local scene, especially if the design, if the desire is to go under now. The only limitation with the global scenes is that the navigation tools that we have are more, you know, suited for like subsurface navigation. So I think it
depends on the customer case, but for sure. Did that answer your question? Okay. Yes.
So how we've gotten around that, how they work with creating elevation surface.
Yeah. Mm-hmm. Yeah.
But then you can see all of the underground utilities and everything.
Yep. That is one way. We've had that silly gridded wireframe view. We see a lot of people doing that too. In fact, one of the other things that they're planning to do in the scene viewer this year is to make that wireframe just completely transparent, so that you don't even have to have it. So we definitely are getting plenty of asks to allow you to go subsurface in global scenes. Another question? Yes, sir.
Well, when you take like a 3D scene of like LiDAR data and post it online there's mechanisms to editing vector data during the mechanism or classifying like point clouds directly online.
Can we do the point cloud classification online? Not yet. And in fact, most of what you can do with i3s today is visualization and then visual analytics. We are getting a lot
we just added for point cloud. So the web scene viewer today actually can allow you, similar to the attributes that I showed, that you can stylize it. Point cloud also was added. Just I think
so you can. I think it's been there. We've had the point cloud, so you can visualize it by classification. So if you have intensity classification,
but you can change it.
Okay.
Yeah, now you can change it.
All right.
You know, if you have intensity or RGB, you can change between that on the web scene viewer.
But
Actually, my next question is do you also load ways to the elevation versus intensity versus classification?
Yeah.
So yes, if the attributes are in the points,
if you authored it.
If it's authored with that data, then yes. With the attributes, then yes. And that's been out there. Which we don't have is analytics up there to say process the data. We are getting a lot of demand for that, especially around i3s point clouds, because they're an efficient way to have these really, really large point clouds. Did you bring up the
I just brought it up, huh?
Did you have the 43 billion point one on your phone?
Oh, yeah.
Somebody just posted a point cloud layer last night from the Netherlands that's got 43 billion points in it, and it actually works pretty well in our browser on the phone. So we're getting a lot of demand for doing this, because if I can do stuff with it quickly and visually, why can't I analyze it quickly? So, any other questions, folks? Yes, sir.
Do you need an image extension in order to serve out a scene layer?
You do not need the imagery extension to serve out the scene layers, and I don't think you need 3D analysts to serve them out either.
You don't need even 3D analysts, because with the ArcGIS portal, 3D analysts already available for you. And it's available at the standard level of licensing. Yeah. So if you have the standard level of licensing, you should be able to generate the cache, be able to publish it on portal. And then online, there's no, per se license. So.
All right. Well, thank you to everybody who stuck it out, which was almost everybody, which is fantastic. And we'll be here for a couple minutes if you have other questions. And you can also just flag us down during the show. So thank you all.
Thank you.